to the Truth in My Days podcast, where we defend the Word of God against the challenges of men.
Hi, I'm Dana Torst, and welcome to another episode of the Truth in My Days radio program. Today, I'm here with John Torst and Jason Chan as they discuss the important topic of creation and evolution. We are continuing from the previous episode. We hope you enjoy.
All right. Another one is short period comets.
Okay.
Do you know what a comet is?
Yeah, so basically it's a big chunk of rock and ice in space, and you can see the tail of it, and that's because on the tail of a comet, it's ejecting a bunch of ice.
Yeah, it's actually mostly you could describe it as a dirty snowball. It's mostly ice with some little rock particles, dust in it. And these fly in gigantic orbits, and they're strongly elliptical in shape, the orbits. And they're not pure circles, they're kind of like flattened circles, ellipses.
Right.
And they have two focuses in this elliptical orbit, and they fly around it. And one focus is the sun, the other focus is out in deep space somewhere. Now, depends on how long it takes to come back around the sun, and that depends on the size of the orbit. Mm-hmm. Comets that take longer than 200 years to come back are called long-period comets, and the ones that are less than 200 years are short-period comets. Halley's Comet, for example, a very famous one that showed up in 1910 and was so bright people thought the world was going to end.
Huh.
That one has a period of 76 years. So
Okay.
it did come back in 1986, and we're all eagerly looking for it. Unfortunately, things are so dark and cloudy, you couldn't really see it this time.
Okay.
But that's a typical short-period comet. Now, you notice as the comet flies, you see this tail behind it. And for most of its flight, actually, you don't see a tail, because what the tail is water vapor. As the comet approaches the sun, one of the focuses of its orbit, the heat of the sun begins to melt it.
I see.
And it gives off this trail of water vapor as it goes around the sun, and then as it moves back into deep space, it cools down again, no tail.
Okay.
So what happens then with this dirty snowball comet, every time it comes around the sun, some of it is vaporized, gives off that nice trail, but that means that it has lost some of its mass.
Sure, yeah.
So a short period comet, and comets are supposed to have formed with the solar system, left over some of the material that the planets were made out of. And these short period comets, because they lose mass every time they orbit the sun, have a maximum lifespan of 10,000 years or so. There's that number again, 10,000 years. So
Interesting.
when the solar system hit 10,000 years, you should have no more short period comets. And yet they're still here. And that's, again, an indication that our solar system is less than 10,000 years old. And that's from R.A. Littleton, Mysteries of the Solar System, Oxford, Clarendon Press, 1968.
Okay. So how would evolutionists explain away this one?
Well, they get pretty desperate here. They have to start resorting to speculation and imagination. One gambit they have is to appeal to the Kuiper Belt. The Kuiper Belt is supposed to be this belt of planetesimals, tiny little planets, planetoids that are too small to actually be a planet.
Okay.
But supposedly there's a bunch of these out past Neptune. And the idea is that every once in a while, some kind of gravitational event knocks one of these into an orbit around the sun, so it becomes the new comet. So indeed, short period comets did burn out after 10,000 years, but you keep getting the supply of new ones.
Oh.
Sound reasonable?
So far, yeah. But yeah, what do you think of this?
Well, there are several problems with this idea. The first and obvious one is there's no Kuiper Belt. At least we certainly have not found one.
Okay.
Right now, it's a product of evolution's desperate imagination. We have detected a few icy planetesimals beyond Neptune. And some would say that Pluto actually should count as a trans-Neptunian object.
Sure.
So we've found a few, but to keep creating short-term comets through all these years would require at least 1 billion of them. And we found, as I say, a few. And those few we found are much too large. For a comet, you should have about 10-kilometer radius to start. And these ones are ranged from 100 to 500. And other observations have created problems. They find that an awful lot of these trans-Newtonian objects are binary systems, which means as they are orbiting around the sun, they are also orbiting around each other. So like the moon orbits around the Earth as both of them are actually orbiting around the sun. This is supposed to be a very rare thing because there's no good natural explanation for how a binary rotation system could start.
Oh.
But they're finding that an awful lot of these, the ones that they found anyway, they're binary systems. I can't really say an awful lot. They haven't even found an awful lot yet, but the ones they found, they're binary systems, many of them. And that means that, where's the explanation? How did this get set up? And if they get knocked into orbit around the sun, like how do they keep rotating around each other at the same time? So there's a lot of scientific problems with it, but it's also, as I said, there's no actual evidence that such a thing even exists. So that's not really an explanation.
I see.
You want another one?
Yeah, let's go for it.
Earth's magnetic field. As you probably know, you're a teacher of physics, you know that the Earth is a giant magnet. It has its own magnetic field.
Yep, that's how compasses work.
That's how compasses work. What other important function is there?
I think one large role is that it also protects the Earth from solar winds. So it protects our power grid.
Protects us, too.
Yeah, it protects us, and the power grid,
Yeah. There are high energy particles coming out of space all the time, but our magnetic fields around the Earth actually deflect these, put some of them into permanent spiral orbits. It's actually very interesting. But the point, and without that, you couldn't have life on Earth, actually.
Okay.
But the interesting thing is, Earth has a magnetic field around it. And the field lines go from the south magnetic pole, up to the north magnetic pole. And the interesting thing about it is the magnetic field is decaying.
Okay.
It's losing strength. It's losing intensity. And it has been decaying steadily over the past 1,000 years. We've got archaeological measurements to that effect. And here's the problem. Imagine if we've got this magnetic field around Earth, and it's been decaying 1,000 years. What does that tell you about what happened before? Well, if it's stronger 1,000 years ago than it is now, and it's getting weaker and weaker, what was happening before that?
There had to have been some maximum.
Yeah, it had to have been stronger before, right?
Yeah.
It's a decay. And here's the problem. Magnetic fields give rise to electrical fields, which are high temperature energy fields. If the magnetic field is strong enough, the energy would just roast any kind of living thing on Earth. 10,000 years ago, this field would have been too strong for life to exist on Earth.
Oh.
We have this from Merrill and McElhinney, The Earth's Magnetic Field, London Academic Press, 1983.
Oh, that's interesting. I've never heard of this before.
Well, this, as we said, the goal of science now is to drive God out. And the more you look, the more you have to ask, like, why are they not telling you these things? Is it because they want to get rid of God? As Professor Larson actually said. Larson, of course, no doubt believes what they're saying, but at least he's got it right, that this is where the theory started from, was a desire to push out God. So, where does this magnetic field come from in the first place? There's only one viable explanation that scientists have come up with. A fellow called Thomas Barnes pointed out that the only possible explanation is that there's an electric current inside the Earth. And you know that from physics that an electric field gives rise to a
magnetic field.
A moving magnetic field in turn gives rise to an electric field and so on.
Yep.
But it has to be a moving magnetic field. This one's not moving. So what happens? The electric current is generating the magnetic field. And as the electric current gets weaker, the magnetic field gets weaker. This is why it's decaying.
Okay.
Yeah, there's no source of energy to recharge it. So if God made the earth originally with this a good electric current inside it, that explains where the magnetic fields come from. But once he set everything in operation is going on, there's no new energy source to replenish the electric current. So electric current becomes weaker through the years, and so the magnetic field that it makes is also decaying. So as the current dies down, the induced magnetic field dies down with it. And that explains why it's being decaying. But as we see, this sets a maximum possible age on the Earth.
So based on this rate of decay, what is the estimate for the maximum age of the Earth then?
Well, we'd have to know how strong the electric current was originally to know. But it's a moot point here because, as we've mentioned, the stronger the magnetic field, the stronger the energy generated, the greater the heat. And so 10,000 years ago, you could not have had life on Earth. It was just too hot.
Right, that's true. Right.
So that's the maximum possible age.
Gotcha. So how do evolutionists deal with this one?
They have an awful lot of trouble. They have an awful lot of trouble because they know the numbers. Okay? So they have to like how? I mean, it's been decaying for this period, and that sets a maximum age. So what do they have to do? Well, they have to try to claim something like it flips. So it decays down a certain point, and then it flips. And then it goes up, and then it starts decaying and flips, and then starts building up. And so they, instead of just having a field that decays, they have to posit this kind of flipping back and forth.
And have we observed this flipping before?
Absolutely not. We haven't observed a flip. Now, there's certain traces in magnetic particles, iron particles, and so on in rocks that indicate that you can have like a little local reversal, certainly nothing worldwide. But there's a bigger problem to that, is if you flip and you build it back up before it decays again, where does the energy come from? This is the problem. Okay, like we said, the God created the electric current with the earth when he made it. It's no power to regenerate it. Now the evolutionists need something to regenerate it. Well, all they can say, and this shows you how desperate they get, is to say that, well, when the magnetic field is decaying, it's not actually losing energy. It's actually storing the energy in non-dipole fields.
Thank you, everyone, for listening today. Unfortunately, we have run out of time, but please join us for the next part tomorrow. Same time and same place. If you enjoy our content and think this is important material, the best compliment you can pay is by sharing this with your friends and family. This helps us out a lot. Also, if you enjoyed today's program, please like, comment, share, and subscribe to this podcast. We would love to hear from you. Thank you for listening to the Truth in My Days podcast with John Torse. We would love to hear from you. Please feel free to share any questions or comments you may have. You can reach us on Facebook, Instagram, MeWe, and YouTube. Simply search Truth in My Days as one word. Again, Truth in My Days as one word, no spaces in between. And you can connect with us. You may also visit our website for more comprehensive material and to learn more about our ministry. Our website is truthinmydays.com. Thank you.